Hello everyone and welcome to this Hackolade tutorial. Today we'll be talking about our Docker-based data modeling automation possibilities using the Hackolade CLI that we're going to be deploying inside a Docker container. Before we do that, let's have a little context. The first thing that you should really understand is that this is something that we want to facilitate because we believe in the power of integrating the entire data modeling lifecycle with DevOps applications. The infinite loop that you see here, which many people know very well from their agile software engineering and DevOps CI/CD integration storylines, is something that we believe should be applied to data modeling professions as well, as it enables so many different new ways of doing things. We believe that in a agile and DevOps oriented context, data modeling has a true possibility to be as relevant as it ever was, and that both are the physical data modeling capabilities and all kinds of iterative optimizations and evolutions, compliance, governance capabilities are going to be enabled by doing this in a structured fashion. We call this metadata as code. That's our tagline to make people understand what this is all about. And obviously, this is greatly enabled by our Git-centric repository strategy, right? So Hackolade doesn't have its own proprietary repository for data models. No, we always rely on Git to provide us with many of those really interesting capabilities in terms of versioning, model comparisons, but also lots of automation capabilities. Why? Because Git, obviously, because of its nature, because of how it was developed, has been integrated very, very tightly with all kinds of DevOps continuous integration and continuous deployment pipelines. This is part and parcel of what people are doing using Git infrastructures. It has been integrated with these continuous integration and continuous deployment pipelines. This is what we would like to enable for data modeling as well, right? So that when you have individuals that are contributing new artifacts to their data models in their local repos, well, as soon as they push these things into the central remote, right, into the Git remote, then automatically there will be a number of steps taken using a command line interface that allow you to basically not have to worry about it anymore. It will just run automatically. The CLI will take care of this, and eventually, all the consumers of the data models will receive what they need to receive based on the work of all of those individuals working in their local repos, but it will flow automatically through the entire pipeline. That obviously doesn't work as well if we're always working on a local machine, on someone's individual workstation in order to make these automations work. And that's why we have introduced this Docker-based automation, so that it can actually run on a centralized piece of infrastructure, on a Docker infrastructure that allows you to run these pipelines automatically over there without having to worry about the individual being online, yes or no. We believe that there's actually two use cases, primary use cases for this type of integration work. First one is governance. First use cases, where we actually start from the evolution of a data model. The data model is evolving and is pushed and is approved into the repository, which then generates some kind of reverse engineering capability to see what's currently inside a database instance. And then we compare this to what we have recently then approved and create a formalization of the difference, which we call a delta model. Based on the difference between what we have just approved and what we have in production, we can generate this alter script that is then forward engineered so that a DBA can review it before they apply it. The first 5 steps here can all be automated. As soon as the individual data modeler pushes the button and releases the new version of the model, all of the reverse engineering can be done automatically, the comparison can be done automatically, the delta model generation can be done automatically, the alter script generation can be done automatically. It's just the review and the application of the alter script that then would have to be done manually. So you can see that there's a huge amount of work that can be saved by doing this in a Docker container, and this will help us with our governance first use case. The second use case is where we have some kind of a code first circumstance or use case, right? Where the developers, because they need some new piece of functionality and they're coding this inside their development environment, they actually make some changes to the database schema. Now, that database schema evolution would automatically trigger the command line interface and force a reverse engineering of that database instance into a new version of the database model, which we can then compare to the originally agreed or documented version of the model, right? And see, what's currently in production, right? The database schema that is currently in production, how does it compare to what we have agreed to? And then we can say, okay, maybe we need to review those changes and potentially merge that into the baseline model. As you can see here, all of the first 3 steps can be done automatically, right? We can trigger the CLI and reverse engineer from the database instance, compare it to the documented model. And then there's obviously a manual step where someone needs to go through the changes and review them, and potentially then again merge the changes into the baseline model automatically using the Docker container. So the principle here is always the same. There's some kind of event that triggers actions, right? Something happens, a commit happens, or a schema change happens, or something like that. And then you have runners that run jobs. There's a workflow capability inside many of these CI/CD infrastructures that allows you to automate the runners that follow from the events. So there's lots of things that you can do. We have a lot of documentation on this, and obviously in this tutorial we will go through some of these in quite a bit of detail. The scenarios that we'll be going through are the following, right? So first we'll reverse engineer a database. We'll simulate that to be done overnight. Then we will compare that reverse engineered model with a baseline model and generate a delta model that formalizes the difference between the two. And then, we won't be doing the review and everything, but, you can probably understand that this can then be taken forward from there on as well. We'll also just quickly simulate, the generation of documentation in HTML and PDF formats for a particular model, right? So there's a new version of the model, then obviously the documentation should be updated as well. So let's dig right in and show you how this is done. All right, let's dig right in. Here we are in our manual page over here, right? So in the online user manual, search for Docker, right? Docker container. And this will lead you to a specific page that is actually not on our website, but on GitHub, right? So this is actually this page. I had it open here already. And what we want to do now first is we actually want to clone this repo, right? So the Hackolade Docker repo, we want to clone that to our local machine. So I'm going to copy this, right? And then I'm going to go to my Hackolade client over here, and I'm going to say, well, why don't we clone this particular repo from a particular URL, right? So this is it. Let's clone it, right? And then we'll put it over here in a new folder called Docker clone, right? Create that new folder, open that folder, and then Hackolade will actually pull from the central repo the files that I need. I can show you this over here, right? So now I've got the Docker clone repo, and I have this particular directory structure that has been added to my local file system. This is important. I am actually going to open up a terminal in this folder, right? Because we will be using that a lot, right? We will be running the Docker based command line interface from our terminal. And I will leave it to you to imagine that this is how you would trigger it from one of your CI/CD pipelines. All right, so we're going to go into the instructions over here, right? So we are going to go into this folder over here. And here you see all the instructions that you need in order to actually start working with this. Right, so the first thing that we want to do is we want to build the image with the normal defaults installed. There's a bunch of options that you could have here as well, but what I'm going to do is I'm actually going to go into my terminal here and see where I am. I'm in the right directory, and I'm going to build the image from scratch in my local directory. Right, so this is going to take a while, so I'll pause this for a second. I'll reactivate it a little bit here, because then you can see that things are actually being installed here on my local file system, but you don't need to wait for all of this, so I'll just pause it again. And here we are. The install has been finished on my local file system. Now, when you look at that file system over here, you see a couple of files that are really important. More specifically, this YAML file over here that you can open with Visual Studio or with an alternative text editor. But what you see here is, a couple of informations about the CLI and the version of the CLI, but specifically also the mapping of the directories, right? So the directories of your Docker container are going to get mapped to specific directories on your local file system, and you will see those come up here a little bit later on. By the way, all of this is explained over here as well, right? So you can see this over here. The instructions are very, very clear. And just to verify if we've actually been able to install the Hackolade Studio CLI correctly, we're going to run this little command here and go to our terminal and run it over there. And then hopefully this will come back and say, well, hey, here's your help instructions for the Hackolade Studio CLI, and that will kind of prove that the installation has been successful. Takes a little bit of time, but this is now running appropriately. You'll see it pop up in a second here, and it will show you the help instructions that you would also normally get from your CLI installation. It's important to understand that this CLI is now no longer running on your local machine. It's actually running on your Docker container. Now, a very important step that you always need to take is you actually need to validate the Hackolade license on this Docker container installation. And the way to do that is a little bit particular. You first need to get a handle of the unique identifier, and you do that by running this particular command, right? It will show you the computer ID of the Docker container in which Hackolade has been installed. And then the next thing that we do is we're going to run this particular command, right? Validate key, and we need the concurrent license key for this as well. So I should really make sure that I have everything, right? So I'm going to go to my terminal again, and I'm going to add my license key to this command, right? I'll do that right there, right? And then I also need to grab the rest of the instruction, which is that I'm going to add this thing here plus the identifier, right? So, and the identifier is this thing over there, right? That I'm going to copy and paste over there. And when I run this, this will actually make the Docker container, which is effectively kind of like a separate machine, it will validate the license with the Hackolade licensing server and make sure that you can actually use the software within the Hackolade container. It shouldn't take very long. Once it has been completed, it says that the license key has been successfully activated, and that means that we can proceed. Note that there's a lot of instructions here for offline activation. Many Docker containers are actually not connected to the internet, so therefore you would want to be able to do this offline. All of these things are well described over here. But what we're going to do now is we're going to switch to a different article over here, where we're going to go through a couple of scenarios, right? We're going to go through a couple of scenarios that are described in this article, and a couple of things that are quite important if you're on the Mac, right? So don't use the virtualization framework, for example, but this is quite specific. But here we're going to go through some example scenarios. And so let's start, right? The first thing that we're going to do is we're actually going to make sure that our Docker container has the possibility to do reverse engineering of a MongoDB Atlas instance. And to do that, what we're going to do is I'm going to switch to my Hackolade full installation over here, and I'm going to show you that I'm going to use the same connection capability that I have over here, and I'm going to export that in an encrypted way to this Docker clone repo. I'm going to add a folder here, right? MongoDB Atlas, and I'm going to save this connection information over there. Why? Because now my Docker container can actually use that connectivity that I've already pre-configured in the visual environment of Hackolade Studio. It can actually use this in our Docker container as well. You will notice that now over here, I have a MongoDB Atlas folder that has been added. It's actually been added in the wrong location. It should be over there, right? So switching that around a little bit here. So but now it's in the right location in MongoDB Atlas, and there's the bin file that my Docker container will be able to use, right? So that's the first thing that we need to do. We need that connectivity file. And now we're ready to actually do a first reverse engineering run. And we do that by running this command over here. Let me just show it to you over here in my terminal. I'll paste it over here. This is the Docker Compose, where I'm doing the reverse engineering of a MongoDB using a connect file, right? That's the file that I just added to my MongoDB Atlas directory. And then we're going to create a new model, right? And that model is going to be called Docker Revenge MongoDB Atlas mflix.hk.json. And I'm going to do this for the sample mflix database on the Atlas infrastructure. So let's do this. We'll run the reverse engineering inside the Docker container. And again, this is going to take a few seconds, so I'll pause it for a while and come back to you in a second. And after a couple of seconds, you will see that the model has actually been saved, right? So if I go back over here now, I will see that in the same directory, I now have this model that was added. Let's open that. Let's open it in Hackolade, open without saving, right? I'll go over here in the data directory, MongoDB Atlas. This is the model that we just created in our Docker container. And here we are, right? So this is all set. Right, we have the model that was generated in our Docker container. And now what we'll do is actually we'll go one step further. What I'm going to do over here is I'm actually going to take an intermediate step and use MongoDB Compass to make a change to the model. Right, so let's see here. I'm in Compass over here. This is sample mflix. And what I'd like to do here is I'm going to create a collection inside sample mflix, which is called animals. And inside animals, I'm going to add some data. And that data is actually going to be like this. Name is dog. Right, so I've added a first document. I'm going to copy that document and paste it and say cat. I'm going to do the same thing and I'll make it a snake. So I have 3 documents in this collection now, in the sample mflix animals collection. Why am I doing this? Because if I now go back and I rerun the reverse engineering task, right, and create a second model, right? So imagine what has happened here, right? So someone has actually gone into our Atlas database and has modified the schema of that database. So we now want to do another reverse engineering and paste this and create a V2 of the model. Right, so the second version of the model that we're going to create by doing the reverse engineering in our Docker container, and therefore, hopefully, it will detect that this new collection has been added to the MongoDB database. Again, this is going to take a few seconds, so let's pause it. And here we are. The model has been saved. Let's see if we can find it quite easily. Yeah, here we go. Right, V2 has been saved over there, right? And I can go into my Hackolade Studio and see if I can open it up. I should be able to open it up, right? That's the second model. And here we are, right? The animals collection has been added to the model. It actually worked. And therefore, our next step is really, really easy. I'm going to compare these 2 reverse engineered models in our Docker container, right? So we have 2 versions of the model. We have them right here, these 2. And we're going to instruct our Docker container to compare these. We paste the command, right? So we have comp mod command with model 1 over there, model 2 over there, and we are going to generate a delta model. The delta model being a formalization of the difference between the 2 models. And hopefully the delta model will show us that now we actually have an additional collection that was added to the MongoDB database. Let's see if this is going to work. Normally this is going to go a little bit faster and it's going to generate this delta model for us. Should go quite fast. Let's see. Right, yeah, here we go. Right, so this is the delta model. Let's see if we can open that up. Open the model in our data directory, and this is the delta model. And the delta model indeed does specify that there was an animals entity added to the model. So again, pointing you back to how you could integrate this into a pipeline. So we have a model, we detect the schema change, we generate another model, reverse engineer another model, we compare those models, generate a delta model. All of this is done automatically with these few simple commands inside our Docker container. There's a couple of other things that you can do, obviously, like for example, generate documentation, right? So I'll very quickly show you how you can generate documentation using the Docker container, right? So here we go. This is the command, right? So it's always the same structure. This one says gendoc from that MongoDB model that we reverse engineered originally, and we're going to generate a PDF, right, which we will put in the same location. We have another one over here that does the same thing, which is it generates the HTML documentation, and we can actually try and run that in parallel. So we now are spinning up 2 Docker containers in parallel, multi-threaded, so to speak, and one is generating the PDF and the other one is generating the HTML. We will see both of them pop up inside this directory very soon. Hopefully this will finish quite quickly, and then you can just see how this works and how you can automate the documentation generation task simply by running this automatically as part of your pipeline inside a Docker container. Oh, here we go. This one has finished. The PDF generation has finished. Here we see it. Right, this is the PDF that was generated, and let's see if the other one is also almost ready. The HTML has also been generated. So therefore that should also be present inside this directory. Here we go. So that's it. This hopefully wraps it up and makes it clear how you can use the Docker container infrastructure to automate your CI/CD pipelines, to co-locate your data inside Git using Hackolade Studio, and then basically save a whole bunch of time by automating these things inside a pipeline. Both GitHub, Azure, Bitbucket, GitLab, they all have their own ways of doing this and of triggering your Docker infrastructure. And hopefully that is something that you can take a look at yourself. That's it for the demo. I'd like to finish this tutorial by pointing you to some really cool reading materials. We obviously have our documentation, we have the blog, we have the social media pages. We obviously want you to try the product for free. I would also like to highlight the fact that there's a large number of actual great books that are available about these topics. MongoDB was the first, but as you will see, there's really great books around Neo4j data modeling, Oracle 23c, Elasticsearch, and we have more coming very, very soon. All of these books are built around the use of Hackolade for their data modeling exercises, and you will no doubt recognize many of the capabilities there. So that wraps up our tutorial, and if you have any questions, please reach out. And other than that, I'm going to wish you a wonderful rest of your day.